Good morning, everyone, and thank you for being here today. I'm pleased to welcome you to this presentation on calculations of dissolution analysis. My name is Dr. S.K. Singh, and I hold a PhD in this field. Over the next few minutes, we'll explore the key concepts and methods involved in dissolution analysis, including practical calculation techniques. I hope you find this session informative and helpful for your work. Let's get started. Today, I want to talk about the dissolution test apparatus. This is a crucial laboratory instrument used to measure how quickly and how much of an active pharmaceutical ingredient, or API, is released from a dosage form into a dissolution medium. Essentially, it helps us understand how the drug behaves once administered, under specific conditions that mimic the body. The key point here is that the apparatus allows us to simulate the environment in which the drug dissolves, so we can assess its release profile. This information is vital for ensuring the drug's effectiveness and safety. Throughout this presentation, we'll see how this test fits into the larger picture of pharmaceutical development and quality control. Understanding the dissolution process helps us verify that our formulations will perform reliably inside the body. Now, let's talk about the calculation for tablets and capsules using UV-visible spectrophotometry. First, we prepare our solutions following the monograph instructions. We start with a blank preparation, which helps us account for any background absorbance. Then, we prepare reference solutions or working standards by dissolving a known amount of the standard in diluents or mobile phase. It's important that the concentration of the working standard in ppm is similar to the concentration of the test sample in ppm, so our results are accurate and comparable. For the test solution itself, we take one tablet or capsule and dissolve it in a specified volume of dissolution medium. This could be 250, 500, or even 900 milliliters, depending on the method. This step ensures we mimic the conditions under which the drug releases in the body. Dissolution testing, as you know, provides critical information about how quickly and effectively the drug releases from the dosage form. This data is essential for quality control, so we can ensure each batch performs consistently, and also for drug development to optimize formulations. Overall, this process helps us understand the drug's behavior in the body and ensures we deliver safe, effective medications. Now, let's look at apparatus No. 2. For this experiment, we use 900 milliliters of a 0.1 molar hydrochloric acid solution as our medium. The testing involves stirring at a speed of 100 revolutions per minute for a duration of 45 minutes. After that, we withdraw a suitable volume of this medium, then filter it to remove any insoluble particles. From the filtrate, we take a specific volume, dilute it with the same solvent to ensure consistency, and then measure its absorbance at approximately 274 nanometers, which is the maximum absorption wavelength for our compound. The goal here is to determine the amount of C8H10N2S, which is the active ingredient in ethionamide, by comparing the absorbance of our sample to a standard solution with a known concentration of ethionamide reference substance, or RS. This comparison allows us to calculate the content of C8H10N2S in our sample. It's important to note that the content of C8H10N2S in the tablet should not be less than 75% of the stated amount. This ensures the tablet's quality and potency. In summary, this dissolution test checks how much active ingredient is released under specified conditions, helping us verify the tablet's compliance and efficacy. Dissolution is a crucial concept to understand because it marks the end of a formal legal entity, such as a corporation or partnership. When a business dissolves, it's not just shutting its doors. It involves a process of winding up affairs, settling debts, and distributing remaining assets. This process can be voluntary, like when owners decide to close the business, or involuntary, due to legal or financial issues. It's important to recognize that dissolution doesn't necessarily mean the business ceases to exist immediately. It's more about the formal steps taken to bring the entity to an end. This concept ties into the broader theme of how legal structures are created, maintained, and eventually dissolved, reflecting their life cycle within the legal system. Today, we'll discuss the evaluation process using HPLC for norethisterone acetate controlled release tablets. First, we set up the dissolution apparatus, which is a paddle type, with 900 milliliters of a 0.3% sodium lauryl sulfate solution as the medium. The paddle rotates at 50 revolutions per minute, maintaining a temperature range of 36.5 to 37.5 degrees Celsius. We take samples at specific time points, namely the 4th, 8th, 12th, and 16th hours, to monitor the drug release over time. For the standard preparation, we accurately weigh about 75 milligrams of norethisterone acetate standard, dissolve it in methanol within a 100 milliliter volumetric flask, and then make up the volume with methanol. From this stock solution, we dilute 2 milliliters to 100 milliliters with the same dissolution medium, then filter it through a 0.45 micron nylon filter to ensure purity. When it comes to the sample preparation, at each designated time point, we withdraw 10 milliliters of aliquot from a zone roughly midway between the surface of the medium and the top of the rotating paddle, specifically, at least 1 centimeter from the vessel wall. We filter this sample through the same 0.45 micron filter to remove any particulates. To maintain the volume, we replace the withdrawn aliquot with an equal volume of fresh dissolution medium, bringing the total volume back to 900 milliliters. Finally, for calculating the drug release profile from the controlled release tablet or capsule, we analyze these samples via HPLC, comparing the results to our standard. This process allows us to accurately determine how much drug has been released at each time point, which is crucial for evaluating the controlled release characteristics of the formulation. Now, let's talk about how we evaluate the release profile of our controlled release tablets and capsules. We use high-performance liquid chromatography, or HPLC, to perform this assessment because it provides precise and reliable measurements of the drug released at different time points. The acceptance criteria are set to ensure our formulation releases the drug in a predictable and safe manner. At the 4-hour mark, we expect between 10 and 40% of the drug to be released. Moving to the 8-hour point, the release should be between 30 and 60%. By 12 hours, we aim for 50 to 80% release. And finally, at 16 hours, the release should be no less than 70% of the labeled amount. These criteria help us confirm that the drug is released gradually over time, maintaining therapeutic levels without causing spikes or drops. When calculating the release for a controlled release tablet or capsule, it's important to compare these measured values against the specified acceptance ranges. This way, we can determine if the formulation performs as intended and meets quality standards. In essence, this evaluation process is crucial for ensuring our controlled release products deliver consistent, effective dosing throughout their intended release period. Similarly, if there are additional time intervals for sample withdrawal, we need to calculate the correction factors at each of those intervals. Then, we keep adding these correction factors to the previous content value, along with any correction factors we've already calculated. It's important to remember that we do not add a correction factor at the very first sample withdrawal time, since that serves as our baseline. This approach ensures that we accurately account for the drug release and absorption over multiple intervals, which is especially crucial for controlled release formulations like tablets and capsules. By doing this, we can better understand the drug's release profile and ensure our calculations reflect the true pharmacokinetic behavior of the dosage form. Let's take a closer look at the calculation process for controlled release tablets and capsules. This is a crucial step because it ensures we achieve the desired drug release profile over time. First, we need to determine the drug release rate, which depends on factors like the drug's solubility, the formulation, and the release mechanism. Then, we calculate the amount of drug that should be released at each time interval to maintain therapeutic levels without causing peaks and troughs. We also consider the total dose, the duration of release, and the kinetics involved, be it zero-order, first-order, or more complex models. These calculations help us design a formulation that releases the drug at a controlled, predictable rate, improving patient adherence and therapeutic outcomes. Connecting this to the overall theme, mastering these calculations is essential for developing effective controlled release systems that optimize drug delivery and minimize side effects. It's a blend of science and precision that ultimately leads to better healthcare solutions. Let's dive into the calculation process for controlled release tablets and capsules. This is a crucial step because it determines how the drug is released over time, ensuring the desired therapeutic effect. First, we need to understand the release rate we want to achieve, which depends on factors like the drug's properties and the target site. Then, we calculate the amount of drug to be incorporated into each unit, considering the release kinetics. We also account for the matrix or coating materials that control the release, adjusting their properties to fine-tune the release profile. Remember, the goal here is to design a formulation that delivers the drug steadily and predictably, minimizing fluctuations and ensuring patient safety. These calculations are fundamental to creating effective controlled release systems, tying back to our overall theme of optimizing drug delivery for better health outcomes. Let's take a closer look at the calculation for controlled release tablets and capsules. When designing these dosage forms, the goal is to ensure a steady, predictable release of the drug over time. This involves understanding several key factors. First, we need to consider the drug's solubility and how it dissolves in the gastrointestinal tract. Next, we examine the diffusion mechanisms and how the drug migrates through the matrix or coating. Another critical aspect is the surface area available for release, which can be adjusted to control the rate. We also look at the thickness and composition of the controlled release layer or coating. By integrating all these factors into our calculations, we can predict how the drug will release over time, ensuring efficacy and safety. This process is essential to achieving the overall goal of controlled release systems, maintaining therapeutic levels while minimizing side effects. For further support, please don't hesitate to reach out. We're here to help with any questions or additional information you might need. Feel free to contact us at any time. And with that, I want to sincerely thank you all for your time and attention today. Your engagement truly makes a difference. Remember, we're committed to supporting you beyond this presentation, so please take advantage of the resources available. Thank you once again, and I look forward to connecting with you soon.